tree method. So this is frequent pattern growth strategy. So we will do the following example. Given the following transactional database, find the frequent item sets with minimum support equal to 3. Using the frequent pattern growth method. So we have again the same database of transactions. Our transactions in this case is A, B, C, D, E is the first transaction. Next transaction, A, B, C. Next, A, there's no B, so I'm going to leave space here so it's easier for us to count. A, C, D, E. Next transaction, there's no A, B, C, D, E. Next transaction, B, C. Next transaction, there's no A, there's no C, there's D, there's B, B, D, and E. And next transaction, there's no A, there's no B, there is C, D, E. So I'm arranging them like this so it's easier to count the number of A's or the number of B's. So the first thing we're going to do with this problem is scan the transactional database, and again we will count the number of times each single item set occurred and write it down, and then we will reorder the items in the transactions in descending order. So we need to find out the count because we want to sort by support in descending order. So let's look at our items, our elements. How many elements do we have? We have A, B, C, D, and E. These are our elements. Is there anything else? these will be the single element sets. We want to create a list and order them by support in descending order. How many times did A occur in the data? 1, 2, 3. And B? 1, 2, 3, 4, 5. And C? 1, 2, 3, 4, 5, 6. And D? 1, 2, 3, 4, 5. And E? 1, 2, 3, 4, 5. So now, what we're going to do is descending order by support. Which item is going to be on the top of the list? C, because C is 6. And next, we have B, D, and E, all of them is equal to 5. We can choose any one, but we would choose them in alphabetical order so that all of our answers is the same, okay? If you don't, you're gonna end up with a different tree than the rest of the classmates. So just always pick them in alphabetical order. So B is 5, next is D, 5, and E, 5. And the last element will be what? Which is the last one? A3. So this will be our order, and now we will order the transactions in this way. Transaction number. So the first transaction will become C, B, D, E, A. So we write down the first transaction C, B, D, E, A. That's transaction number 1. Next one will become C, B, A. That's transaction number 2. Next one will become C, D, E, A, right? C, D, E, A. Next transaction will be what? Look over here. We are reordering these items according to this order. So these will become what?
C, B, D, E.
C, B,
D, E.
C, B, D, E. C, B, D, E. That transaction number 4. And next
CB.
one,
C, B.
CB. And next one, BB. B.
D, E.
This one will not change, right? It will stay like that. D, D, E. That's number 6. And the last one,
CD. What? Same.
CD, stays the same. Okay. So that was the first thing that we did, recording the transactions. Next, we're going to build a tree in the tree. We have nodes. The nodes are denoted with circles, so always the first one will be node. This is a node, and we will start. This is the root of the tree. We will start from the root, and we will start with our first transaction, and with the first item in the first transaction, which is C. And what we're going to do is start from the root and see, does this node have a child node named C? If it has a child node named C, we will increment the count for that node. If it does not have a child named C, we will create it. So does it have a child named C? No, there's nothing here. So we will create it. Right here, C. Next, we will create a link to the node from the parent, and we will increment the count for that node. So the count is now 1 because